Okay, John is given two sunflower plants. One plant is 16 centimeters high and the other is 25 centimeters high. John measures the height of each plant at the same time every day for a week. He knows that the 16 centimeter plant grows 4 centimeters each day and the 24 centimeter plant grows 3.5 centimeters each day. Draw a table of the heights of the two plants each day for the week, starting on the day that John got them. Okay, so what we're going to say is day one. We can say that this is called in plant A and plant B. Okay, so plant A can be the one that's the plant A can be the 16 centimeter high one, and plant B can be the 24 centimeter high one. Okay, and you can just call this the height of A and the height of plant B. I suppose it'd be handy to put in plant A because you need to know what you're talking about. Plant A. Okay. Now, what we're going to do next is just going to quickly now we need 7 days, which means that we're going to need 7 sections here. So just 1, 2, 3, 4, 5, 6, and 7. Okay. So here's our table here. Now, and what we can call this is the days. Okay, so day 1, day 2, day 3, day 4, day 5, day 6, day 7. So just basically with the 16 centimeter, just keep adding on centimeters. Just keep adding on 4 centimeters because it grows 4 centimeters a day. So that's not too bad. 32 centimeters. Then it's going to be 36 centimeters. 42 centimeters. And for the second one, it grows at a slower pace. So eventually this one is, they should overtake each other eventually, okay? The plant A should overtake plant B because plant B doesn't grow as fast as plant A. So 25.7, 31, 34.5 centimeters. Just keep adding on 3.5 every time. 38 centimeters, 41.5 centimeters, 41.5 centimeters, and 45 centimeters. Now, write down two formulas, one for each plant to represent the heights of any given day, clearly stating what it means each letter is in the formula. Okay, so what we're trying to get at here is sort of like equation of a line formula. Okay, so what's happening is both plants, or one plant will start with the first plant is starting off at 16. Okay, so you imagine 16, 20, 24, 30. Okay, and if you imagine that this plant, okay, so day 1, day 2, day 3, day 4. Okay, so day 1 it's on 16. Then day 2 it goes to 20, and then day 3 it goes to so basically the height of the plant, alright, is calculated by, or the current height of the plant is equal to original height, equals to growth per day multiplied by number of days plus original height. So for example, if I wanted to get how many after, let's say, 2 days, okay, so on day 1 the plant was 16 centimeters, day 2 was 20, okay, so I wanted to figure out how big it was on day 3, okay, let's say, so that's going to be 2 days worth of growth, okay, so day 3 is 2 days worth of growth. So if I multiplied 2 by 4, 2 days of growth from day 1, and added on the original height of 16, what I'd get there is 8 plus 16, which is 24. Okay, so that's how these formulas work. Now, It's very similar to y equals mx plus c. The slope of the graph is basically how much your plant is growing. Okay, so if we were to have the second plant in here, which starts off at 24, its slope wouldn't be as high. Okay, so what's going to happen next is with this worded equation, what we can do now is try and figure out how we're going to represent this by letters. Okay, so what I'd like to call this is, I'll call this HA, height of plant A. So HA is the height of plant A. What it equals is the number of days, number of growth per day. So that's 4t. 4 is the growth per day. Number of days, let the number of days be t. T is the number of days, and the original height is 16. So you multiply the number of days by 4, and then you add on the original height. So that's basically the same thing. Now we're going to do it for plant B. HB, which is the height of plant B. It grows not at 4, but at 3.5 centimeters per day. That's T, and its original height is 24. Okay. Now, HA means height of plant A. HB means height of plant B. And T is time of growth in days. Okay. So time of growth each day. Each day. Okay. Now, it's very similar to, if anybody remembers, y equals mx plus c. Okay, c is the y-intercept, m is the slope. So the slope of the first plant would be 4, the slope of the second plant would be 3.5. The x value, which is usually on the x-axis, is now t. So we're going to do t on the x-axis, and instead of y, we have height. So height on the y-axis and time on the x-axis. Okay. John assumes that the plants will continue to grow at the same rate. Draw a graph that represents the heights of 2 plants over the first 4 weeks. Now remember guys, it's 4 weeks, okay? So, best to break it up. Okay, so 4 weeks is, let's say, 28 days, okay? So, what we'll do is, we'll do the growth every 4 days. Okay, now what you're going to have is we're going to start off with a big line here. Okay, and then we'll have one going over here. Now, first of all, we're going to draw the time in. We're going to draw the time on the x-axis, which is this part here. So we're going to go for time here. And time, we're going to do every 2. We're going to go up in 4s, right? So 4 after 4 days. It's this much after 4, 8, 12, 16, 20, 24, 28. Okay, we do that in days. Okay. Now there might be one problem with doing an axis like this. If you're to get an intersection here, it might not be the best. So usually when you're doing your graphs, you want to make them as long as you can. So looking at this graph here, I might have been able to actually go up in 2s instead. Okay, so maybe I should have went up in 2s. We'll see if this option, the bigger you can make the scale, the more accurate your graph will be. So we're just going to see if we'll get away with going up in 2s. 4, 16, 18, 20, 22, 24, 26, and 28. We do indeed. We get away with going up in this, okay? Now, what's going to happen next is I need to find a suitable enough scale for this, okay? So draw the graphs represent the height of the plants over the first 4 weeks, okay? So what we do is day 0, okay? The very first day, what height were they? So on day 0, what's going to happen is we had to find the heights. Day 0, HA was 16, and HB was the height of plant B is 24 centimeters high. Now remember, this one grows at 4 centimeters per day, and this one grows at 4 centimeters per day, and this one HB grows at 3.5 centimeters per day. Now the handy thing about the way they grow is it's a straight line, okay? So because it's a straight line, what we can do is we can find the first point and the last point. So the first point is on day 0, so remember XY axis, time is on the X axis, and on the Y axis is height. So the first point for each of them is the height is 16 and the day would be 0. On the first day, or on the 0th day, he's 16 tall. Another point for the second graph, so do graph A and graph B, or sorry, line A, line B, and another point on line B would have been 0, 24. Now, using our formulas that we had in the last section, we're going to calculate what is the end of height A at the end of the 4 weeks. So height A was 4t plus 16. Now after 4 weeks, it should be 28 days. Okay, so t equals 28. So you can see how tall it is after 20 days. So HA equals 4 times 28 plus 16. So after the 28 days, how tall will plant A be? 128 centimeters. Okay, and plant B, the height of B after all those days, we 3.5 multiplied by t and plus 24, so it grows 3.5 per day. So 3.5 multiplied by 28 is how much it grows by, plus the original height of 24. Equals 122 centimeters. So it figures out that plant B actually comes out shorter than plant A. So that's going to be 28, 2 more points. Okay, it's going to be 28 and 122. And the next point is going to be over here, which is going to be 28, 128. Okay, so 0.16, A is going to be 0.16, 20, 28, 128. B has 0.24, and it ends on 0.24 ends on 28 and 122. Now, what we got to do next is we got to figure out the right scale to start off with. The first point we have to start off on would be 16. Okay, so we'll start off with 16 up here. Okay, and we got to find a decent scale all the way up to 128. So look up all the way to the top, and you're going, okay, this is actually a reasonably steep graph here. Okay, so what we can do, I'll actually just try and fit it all into the one graph here. So I'm going to go up in I'm hopefully going to go up in, we should use the full page, which means I'm going to go up in 4s. Okay, so I'll start off maybe at the very bottom. I'll start off at 16 here, and I'll go up in 4s. 16. So if I go up in 4s, every 2 is worth 8. Okay, so 16, 24, 32, 40, 48, 48, 56, 64, 72, 80. Go up again to 100, 120, 100 sorry, not, 88, 96, 104, 112, 120, 128. So that's what we're looking at here, okay? Now, we're going to start off with our first one, which is 0, 16, which is here. And then we're going to go for 28, which is this line here. 28 and 128, which is going to be there. Okay. So what we're going to try and do is we're going to try and link these guys together and see what we can do. Oop. So what I have to find is, because I can't do this, you just draw the two arrows together, okay? So we might find the middle point between the two of them just to make this a bit easier. Okay, so to get the slope of this, we basically know that the next one in line, the next point is basically going to be, it's going to grow up after 2 days, it's going to be 28. Okay, so we know it's going to go here. 2 days going to go 28, so I can draw the line to 28. I know the slope should be 4. Okay. First part. Go again. And it should cut straight through. There we go, there's the first line done, okay? Now the second line is going to be harder because 3.5 is harder to do, okay? So that should all be one line. Straight as it can go, okay? Next line is going to be starting off at 24, 0, 24. 0, 24. Okay. And I know that 4 days in, it'll be at 38. Okay. So 4 days in, it will be at 38, which is there. Okay, so 0, 24 to 38. So here's what we're going to do. Just going to join this one to here. So we can do it. And we know that the last point is 28, 122. Okay, so 122 would be here. Okay. So what we might actually do is get a different colored line for this one, just to make it easier to see. And go red. So all you have to do is the first point and the last point, and you should be alright. Okay. We scroll up, and as you can see, it's bang on target for hitting that point there. There we go, there. Okay. So what we can see is the line of intersection of the 2 points is coming in around here. Okay. So I reckon that line, this point here, just check out the intersection point. It'd be 84 centimeters, and the time, 84 centimeters is when they're the same height, and the time it takes for both of them to reach 84 centimeters is 18 days. Okay, so we'll just have a look at that in a second. Alright, next part. From your diagram, write down the point of intersection of the two graphs. Okay, so that's what we just did there. 18 days, 84 centimeters. Okay, so 18 days, 84 centimeters. Now, by the looks of it, my graph might have been slightly off, so I'm just going to have another look at my graph here. Okay, so we redrew this and we're looking for the point of intersection, right? So here's the graphs. The blue graph represents plant B, the black line represents plant A. We're going to figure out where they both intersect each other, okay? So what I'm looking at here is just the point at which they both intersect each other. Now it'd be easier to do on, I think it's just eclipsing each other around here, okay? And we can see here is that it's about 80, that's 84, maybe halfway up, about 82 centimeters high. This point should be the point around 82. So just draw some dotted lines out to see where it actually intersects in. So about 82 on the y-axis, so 82 centimeters high. Then on the x-axis, draw all the way down. So maybe you're talking 6.5. Maybe look at it a second time just to make sure you got it accurate. Okay, maybe 16 here. Maybe just, yeah, maybe just a bit underneath 16.5 days, but it looks of it, so it didn't work out exactly the way you wanted. So about 82 and 16.5 days. Okay, so 82 and 16.5 days. Okay, so slight inaccuracies in the graph, so just make sure you're slightly drawn, you're slightly better with the solutions. Okay, so what it is here is 82 and 16.5. Okay, so 16.5 on the x-axis, 16.5 days, 82 tall. Now explain what the intersection means with respect to both hands. The intersection means the height at which and the time taken for both plants to be the same height. The height and time in which both plants have equal heights. Okay. Now that's what I got in my graph, okay? But on the back of the book, you could say, some people say 70 and 80. So you can see I slightly made a slight error on the computer there, okay? 70 and 80. Now, check your answer in part D using the formula of part 1. So if HA equals HB, so what should happen here is HA should be, the height of A should equal the height of B. So this means the height of A is 4t plus 16, and this equals 3.5t plus 24. Bring the t's over one side, and 4t minus 3.5t gives you a half t, so 0.5t, and then we have 24 minus 16 on the other side equals 8. Okay, so 0.5t equals 8, and then t will equal 16. Okay, 16 days. Okay, so the answer should have been 16 days. The point intersection can be found either by reading a graph or using algebra. State one advantage of finding algebra. Algebra is more accurate. Algebra is more accurate than the graph. John's model for the growth of plants might not be correct. State one limitation of the model that affects the point of intersection and its orientation. The plants might not grow at the same height. At the same height, at the same rate all the time, right, as they get bigger. This may result in a different point of intersection. might result in a different point of intersection where they're both the same height, or they may never be the same height, or no intersection at all. Okay. Now, next one. Question 7. Okay, so number question 7. Now, what are we doing with question 7? Okay, write down the value for which hk equals 50. hk is x squared plus 1. This equals 50. Bring over 9. X squared equals 49. X could be equal to the square root of 49, which means it could be plus or minus 7. Write down the value means only one value, but it can be plus or minus 7, but I think the answer we're looking for is 7. Okay, so we go for x equals 7. Okay, so but it can be plus or minus 7. Now, next one. Let g of x equals x 1 over x minus 2. Okay, complete the following table. So g of 0 is 1 over 0 minus 2, which is minus a half. G of 1.5 is 1 over 1.5 minus 2, which should be, the answer to that should be minus 2. Okay. 2.25. G of 2.25 is going to be 1 over x minus, 1 over 2.25. Replace x with 2.25 minus 2. And that's going to be 4. This one's going to be 2. G of 3 is going to be 1 over 3 minus 2. It's going to get us 1. And finally, last one, g of 4 is 1 over 4 minus 2, which is going to give us a half. Okay. Now, draw the graph of the function in the domain. So we got to draw this graph now, okay? So in order to draw this graph, we'll just we have to get the x values and the y values, okay? Now, let's find 2 points to do this, okay? So what we need to do is we need to draw all these points. So we're going to need an x-axis and a y-axis. Now, the x values start from 0 to 4. Okay, so we're going to space them out nicely. Zero to 4. Okay. So each tree is going to be worth 1 point. Okay. So what we're going to have here is going to do this is 1, 0, 1, 2, 3, and 4. Okay. Now the y values can go anywhere from a half to 4. So we'll go open ones 1, 2, 3, and 4. And we're actually going to need minus 2 as well. So we will also get minus 1, minus 2, minus 3. Now, what we know from maths is that this part on the bottom, if x equals 2, it doesn't work. It's 1 over 0. This is what's referred to as the asymptote. So what we can do is we can put a big line through the middle here. And we'll make it the green line here. This is x equals 2. It can't pass out x equals 2. This sort of graph can't, okay? So it can't go by x equals 2. Okay. Now, the next part we have here is we got to draw our graph. 0 and minus a half. So 0 and minus a half is located here. We'll do it in two sections, a red section and a blue section. So 0 minus a half. Now, making the points much smaller is a good way to ensure that your graph is accurate. Okay, so might be something that we might have done in the last one that didn't make it as accurate. So make it nice and small. So that's 0 minus a half, 1 minus 1. 1 minus 1 is here. Okay. 1.5 minus 2. 1.5 is located around here. Minus 2. 1.75 is minus 4. So 1.7, that's about 1.66. 1.75 is minus 4, so we have to go all the way down to minus 4. So so we need to get minus 4 included on this graph as well. So minus 4 being here, need to get included. So it's minus 1 and 7, like 1 and 3/4 is basically 1.75 is around here. So 1.75 is at minus 4. It's around here. Now we can see the shape of the graph as it's bending away from the x-axis. It comes in very tight to the y-axis, like so. It comes very tight into x equals minus 1. Okay. Now the blue line, which is the opposite. 2.25 is a quarter, so basically quarter over 2. So that's 2.3. 2.25 is around here. Okay, so 2.25 is around there, and it's up 4, so it's about here. Little dot. Make sure get the accuracy up. And then the next one is 2.5 and 2. So 2.5 is roughly halfway. And 2. Next one after that is 3, 1. And next one after that is 4.5, which is here. Just going to glide in. There you go. So now we have both graphs done. Okay. Now next part. Okay. F of x equals x minus 5 over x. Find the derivative. Okay. So remember, there's two parts to this question. We're going to lock off this part and get the derivative of 5 over x. So 5 over x is a quotient rule, where u is 5 and v is x. So once again, the quotient rule. Quotient rule is dy dx equals v du dx minus u to v dx all over v squared. So u equals 5, du dx equals 0, v equals x, therefore du dx equals 1. So it's going to be x times du dx, which is 0, minus u times the v dx, which is minus 5 times du dx, which is 1, all over v squared, which is x squared. Multiplied out, we get minus 5 over x squared. So when we differentiate this, we differentiate x, we get 1. Differentiate 5 minus x, what we're going to get is minus 1 times minus 5 over x squared. Multiply them in. What happens is we get 1 plus 5 over x squared. Now, the next part of that is we must find the coordinates of 2 points at which the tangent of the curve is parallel to the line y equals 6x. Now, remember, the slope of lines is the first derivative of dy dx. And remember, y equals 6x. Use the formula y equals mx plus c. The slope c is 0 and m is 6. So the slope is 6. Because remember, tangents are lines. Lines to the curve are 6. Right? So the slope is 6. Now we have to find the coordinates of 2 points, which means we have to find 2 x values and then 2 y values as well. Okay, so to find the x values, we use what we just did a second ago, 1 plus 5 over x squared. 1 plus 5 over x squared equals to 6. Okay, so what we're going to do next is we're going to bring the 1 over the other side, and we get 5 over x squared turns into minus 1 equals 5. Then we know that 5x squared equals 5. X squared therefore must be equal to 1. X equal to plus or minus 1. Now, what we got to do next is we got to get y. Y is x minus 5 over x. So, we're going to test out both points. When x equals 1, it's 1 minus 5 over 1. Y equals minus 4. So, one point is 1 minus 4. When x equals minus 1, it's going to be y is equal to minus 1 minus 5 divided by minus 1. Y equals minus 1. Minus 5 divided by minus 1 is plus 5, so y will be equal to 4. So there's 2 points, 1 minus 4 and minus 1 plus 4. Okay, next question. Question 6. Differentiate with respect to x. X squared differentiate into 2x. Minus 6x differentiate into minus 6. 1 differentiates into 0. Differentiate 5 minus 3x from first principles. Now remember what first principles is. F of x equals 5 minus 3x. F of x plus h is the second step, where it's equal to 5 minus 3 times x plus h, which is equal to 5 minus 3x minus 3h. Third step is f of x plus h minus f of x, which is 5 minus 3x minus 3h. Now remember the minus and the brackets. This is where everybody loses out. You forget to put the brackets in. Okay? And when you put the brackets in, you don't make these mistakes. 5 minus 3x minus 3h minus 5 plus 3x. Basically, everything that isn't a h should disappear off by this point in the question. So we get minus 3h. Now the next part is f of x plus h minus f of x all over h, which is minus 3h over h. And that equals minus 3. Then finally the last one is limit as h approaches 0 of f of x plus h minus f of x all over h. And because there's no h's left, it's still minus 3. Therefore, dy dx equals minus 3. Next part. Given that, okay, so this question here is a product rule question. The reason for identifying that is they're being multiplied by each other. Okay, so the product rule is basically dy dx so to be u times the v dx, p times the u dx. Okay, so we have to differentiate and then put in x equals 2 into our answer. Okay, so it should be reasonably easy. So u equals x squared minus 4. Differentiate. And we get 2x minus 4. Next one should be phi equals 3x minus 1. The v dx ends up to be 3. So what we're getting here is x squared minus 4 times 3 plus 3x minus 1 times 2x minus 4. Now, there's no real need to multiply this out because we know that x is going to be 2. So I might as well just put 2 in now. So we're going to get 2 squared minus 4 times 3. We know that that's 4 minus 4 times 3. 0 times 3 doesn't exist because 0 times 3 is 0. No bother there. Next one, 3 times 2, 6. 6 minus 1 is 5. And then the last one, 2 times 2 again is 4. 4 minus 4 is also 0. So the full thing, the answer is 0. Okay. Now it'd probably be a good idea just to make sure that you show y it's equal to 0. Okay, so basically 4 minus 4 equals 3. 0 times 3 minus 5 times 0 equals 0. Okay, so that's the when x equals 2. Okay. Sorry, excuse me, there was one mistake made in this question here. When you differentiate the 4, you get 2x. So it's actually 2x, right? And as stated before, what happens is 2 squared minus 4 is 0. 0 times 3 is still 0. And then 3 times 2 minus 1 is going to be 5. 2 times 2 is going to be 4. It's going to be plus 5 times 4. And the answer is going to be 0 plus 20 equals 20. So the answer is in fact 20. Okay, just be sure just not to make easy errors differentiating at the start, okay? Now, next one. The speed v of an object is given by v equals 96 plus 4t minus 4t squared. This means the first derivative is acceleration, okay? Because remember, the initial equation is given in terms of v. At what times will the speed of the object be 96 meters per second? So v equals 96, which means that 96 equals 96 plus 40t minus 4t squared. The 96s will cancel each other out. And we're going to get is 0 equals 40t minus 4t squared. Some guys would like to change that around. So multiply this side by minus. So you get minus 40t plus 4t squared. And then what you can get here is 4t squared minus 40t equals 0. Now what you got to do is you got to factorize. If you're stuck in the exam, you could try the minus b formula where a equals 4 and b equals minus 40. C isn't there, so c equals 0. You could try that if you get stuck, but you should know that there's t's in both of them and there's 4's in both of them. So 4 into t minus 10 equals 0. So it can happen at 2 points, okay? The first thing, you split it in half, so either 4t equals 0 or t equals 0 divided by 4, which is still 0. So t equals 0 or t minus 10 equals 0 and t equals 10. Okay, so find the times. That's plural. That's why we got two answers. What will the acceleration of the object be at 2.5 seconds? Acceleration is equal to the v dt for this one, and that means that we got to differentiate it, and v equals 96. So v equals 96 plus 40t minus 4t squared. So let's differentiate this. 96 goes, 40t turns into 40, 4t squared turns into minus 8t. We know that t equals 2.5, so it's going to be 40 minus 8 times 2.5, and 8 times 2.5 is 20, so 40 minus 20 So it's going to be 20 meters per second squared. Okay. At what time will the acceleration become negative? So at what time will 40 minus 8t become less than 0? Let's bring the 8t out of the other side. So 40 is less than 8t. Spin them around. This means 8t has to be bigger than 40. And this means that t is greater than 40 over 8. T will be greater than 5. So anytime it goes over 5 seconds, what value of t? T greater than 5 seconds, okay? Okay guys, that's the end of this exercise.